Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam LTAM. Consider a continuous whole life annuity of 1 per year issued to a 40-year-old given the following additional information. For all t greater than or equal to 0, the force of mortality at age 40 plus t is 3% with probability 0.8 and 6% with probability 0.2. Now this may be confusing, so I'll explain to you what I mean by this assumption. This is saying that the force for all those future years is one or the other with these probabilities. It's not that it can be that it's 3% for some years and then it jumps to 6%. No, this is randomness which sets the force for all the future years. So either 3% or 6% with these probabilities. But once it's one of the two, it is this way for every future age. It's the only logical interpretation of this, because otherwise it would be extremely confusing, but still, I just want to make it clear. The force of interest is 2%. Y is the present value random variable for this annuity. We want to find the actuarial present value of this annuity. We want to calculate the variance of it. And we want to find the probability that Y is less than the expected value of Y. And here's the solution. So we have the expected value of Y given the value of the force, which the force is random here. It's one or the other. So it's really a kind of a Bernoulli trial, but not exactly, because it's a constant plus a multiple of Bernoulli trial, but still like a Bernoulli trial. This, once the force is fixed, the present value of life annuity is 1 over mu plus delta. So in this case, it's 1 over 0.03 plus 0.02, which is 20, for mu 40 plus t equal to 0.03, and this happens with probability 0.8, or it's 1 over 0.06 plus 0.02, which is 12.5, for mu for 40 plus t equal to 0.06, which happens with probability 0.2. Therefore, the expected value of Y is the expected value of this random variable that we just calculated, and that's equal to 0.8 times 20 plus 0.2 times 12.5, and that's 18.5. To calculate the variance, we recall the formula that the variance of Y is equal to the expected value of the variance of Y given the force, plus the variance of the expected value of Y given the force. That's a standard formula for a relationship of conditional variance to overall variance. You need to know it, of course. You should know it from exam P. We just calculated E of Y given the force in the calculation in part A, so we have it. And from it, we can calculate the variance of this expected value. Well, it's a variance of a constant plus a multiple of Bernoulli trial. You can view this as 12.5 with probability 0.2 and 20 with probability 0.8. That's equal to a constant 12.5 plus 0 with probability 0.2 and 20 minus 12.5, which is 7.5. with a probability 0.8, and therefore that constant 12.5 has no effect on the variance. So all we need to do is figure out the variance of a multiple of a Bernoulli trial, which is that number that it gets multiplied by, 20 minus 12.5, which is 7.5 squared, and that's multiplied by a variance of a basic Bernoulli trial, which is always P times Q. So 0.8 times 0.2 times 20 minus 12.5 squared, and that's actually 9. But we have the other part. We need to also figure out the variance of y given the force. So we need to know the variance of y under constant force. In general, under constant force, variance of y is 1 over delta squared times the variance of life insurance. And so in this case, 1 over delta squared, in case of constant force always, 1 over delta squared times mu over mu plus 2 delta, that's the second moment of life insurance, minus the square of the first moment, which is mu over mu plus delta squared. So we write it out, we recalculate it, and this ends up being mu over mu plus 2 delta times mu plus delta, the whole thing squared. And then, for each of the values of mu, 0.03 or 0.06, we just do this calculation and we get variance of y given mu to be either 171.428571 with probability 0.8 or 93.75 with probability 0.2. And then we need the expected value of that, which is 0.8 times 171.428571 plus 0.2 times 93.75. That's approximately 155.892857. And the variance is the expected value of the variance plus the variance of the expected value. So 155.892857 plus 9, and that's 164.892857. Okay, and what is the probability that y is less than E of y? What is the probability that y is less than 18.5? And then that's 0.8 times the probability that y is less than 18.5, given that mu is 0.03, and 0.8 is the probability that mu is 0.03, plus 0.2 times the probability that y is less than 18.5 times, given that mu is 0.06, and of course 0.2 is the probability that mu is equal to 0.06. So this is a form of application of law of total probability. Well, but under constant force, what's the probability of being less than something? Well, that's 1 minus the probability of being more than something, and the survival function under constant force is the survival function of exponential distribution, which is e to the minus the force times the time. The time is 18.5 here, the force is 0.03 in the first case, and 0.06 in the second case, and we just do the calculation, and we get approximately 0.4748304. Please remember this is copyrighted material. The problem was created by me and the solution is mine. The problem was actually it's related to a question I got from one of the people who subscribed to the channel. I don't know the source of the problem, so I just wrote a similar problem, and here's a solution. I hope it's helpful. Study hard. Good luck in your studies and good luck on the test.